Of course, if we take a real number, add it to an imaginary number, we come up with a complex number. So I'm guessing that if we take a cow, add it to Godzilla, we end up with Cowzilla. Okay, oh, maybe that wasn't that humorous. As a kid, a couple of popular cartoons were the Archies and Scooby-Doo. I really liked Scooby-Doo. When Josie and the Pussycats came out, I'm like, oh, come on. Right? They had one character that looked like it was a combination of Velma and Shaggy from Scooby-Doo. They had a character that looked like they just stole Fred from Scooby-Doo. They had a character that basically looked like it was stolen from the Archies. And of course, just like the Archies, they all played guitars and banged on drums. So it's like, ugh. But anyway, I kind of thought about that, grabbing your imaginary number, your real number, putting them together and calling a complex number. How you see that where you see some obvious lifts with music, animation, TV shows, movies, etc. Okay, so let's multiply some complex numbers. Radicals involved this time. Right, first, well, 7 times 4, 28. Outer, well, 7 times 3 is 21. There is also an I. There is also a root 5. Inner, well, there's a negative symbol. There's a 4. There's an I. And there's a root 5. Notice why I put the I in front of the square root symbol. Right, because if I put it behind the square root, it might look like it's supposed to be inside. And so even though we usually want to keep I till the very end of the term, we actually put the square root behind that. And now for last, this is where it gets kind of cool. Negative times positive comes out negative. And of course I have a 3. But I times I makes I squared. Square root of 5 times square root of 5 is square root of 5 squared. Next example, I'm going to do that a little bit differently to show you the other method, all right? But here I did it as square root of 5 quantity squared. Of course, O and I will combine, as they usually do. 21 subtract 4 got me that 17. I still need the I and the root 5. And now with that last term, I squared will be negative 1. And of course, square root and squared cancel out, so that just leaves me with that 5. 3 times 5 is 15. There's a negative on the 3 and a negative on the 1, so negative times negative is positive. Finally, 28 plus 15 is 43. And so there is the example, or I should say there's the answer to this example. Try another example. Again, first, outer, inner. Now, on last, I'm going to show you the other way I could have done this, right? Instead of doing square root of 2 squared, I said, hey, square root of 2 times square root of 2 is going to be square root of 4. Right, so this is the other method I can use. Of course, O and I still combine. And square root of 4 is 2. So I would have gotten the same thing, right? If I'd done square root of 2 squared, I would have ended up with 2. And then, of course, if I do square root of 4, I end up with 2. Of course, it looks like I can multiply that out, combine like terms. There's my answer. Again, if I go a little bit too fast, hit pause, rewind. Okay, let's do a third example. You say, hey, this will go quick, but I don't even see any square roots. Of course, that exponent of 2 tells me I need 2 of those sets of parentheses. And I can do first, outer, inner, last. O and I combine. Negative 10 and negative 10 is negative 20. So there's a negative 20i in the middle. I squared, of course, is negative 1. 25 subtract 4 is 21. There's the answer. Okay, one more example coming up, and I gotta slow down. Notice on this example, the exponent is a 3. So I need 3 of those equal factors, right? I need 3 of those 2 plus 2i root 3s. So how do I multiply? Well, think about if we're just going to multiply plain old numbers. If I gave you 3 numbers to multiply, you would multiply the first 2 numbers together, get an answer, then multiply by the third number. So I have to do the same thing here. I'm going to multiply the first 2 together, and then after I figure out that answer, I'll multiply by the third one. First, outer, inner, last. You'll notice that I went back to doing the root 3 quantity squared. I could have done root 3 times root 3 is root 9. I'm going to get the same thing either way. O and I will combine, right? 4i root 3 and another 4i root 3 gives me a grand total of 8i root 3. I squared, of course, is still negative 1. Root 3 squared, of course, is 3. If I had instead written it as square root of 9, guess what? It'd still be 3. 4 times 1 times 3 is 12. The 1 was negative, so it has to be a negative 12. 4 subtract 12 is negative 8. So I finally have the answer from multiplying the first 2 factors together. I've got negative 8 plus 8i root 3. Now that I have that answer, I can multiply it by the third factor. And this is where the magic's going to happen. This might blow your mind. First, well, I'm getting negative 16. Outer, well, negative 8 times 2 gets me a negative 16. Don't forget about the I. Don't forget about the root 3. Inner, well, 8 times 2 is 16. This time, however, it's positive. And of course, I still have the I root 3. Last, 8 times 2 is 16. I times I is I squared. Square root of 3 times square root of 3 is square root of 3 squared. Hey, look at O and I. Is that magical? Those add up to 0. They cancel out. So I've got the negative 16. O and I canceled out. And then if I look at L, well, I squared becomes negative 1. Square root of 3 squared becomes 3. So that becomes negative 48, right? 16 times 3 is 48. But then I have to multiply by negative 1. And then negative 16 subtract 48 is negative 64. Now that's pretty cool. We started with some weird expression raised to the third power. That weird expression included the imaginary number I and a really weird number, a square root of 3. And look at what we came up with. This is foreshadowing of what's going to happen with the next lesson. Right? First lesson, we just kind of figured out, oh, the number I is the square root of negative 1. And then we spent some time just practicing adding, subtracting, and doing a little bit of FOIL. Today we're doing some more multiplication with FOIL. It's getting a little bit more intense. But it's all leading us up to a really awesome thing. And this is a little foreshadowing that we had some really weird mess at the beginning. And we end up with a tidy answer of negative 64. So there's going to be a worksheet to do. And if you can get through the worksheet, you'll be done for the day. I think this is maybe the first lesson of this unit that might be a little bit tricky. I think those first 2 lessons, you kind of breeze through them. This one might be just a little bit slower, but surely manageable. And then next lesson, next lesson, I'm still designing it. I might have to break it up into 2 different pieces. because it's going to involve some factoring, and I might decide to review the factoring skills first before we throw the crazy imaginary number I and complex numbers into the mix. But we'll do something next time.